Let's see some life applications. So we apply mathematics in life. Let's see, the sum of two numbers is 24. So this gives us an equation, right? If we the two numbers, so let's call one number x, the other number y. The sum means add them up means equals to 24. Right, so we translate this English into mathematical equation. One number we'll call x, the other number we'll call y. The sum, we add those two, is 24 equals 24. Let's see what we have to do. Find the numbers. So we want to find x, y. If their product, the product means we multiply those two, right? X times y, to be the maximum. So how do we find the maximum? Well, let's call the product P. So product of those two, P equals to xy. So I have this equation, and we have the first equation, x plus y equals 24. So how do we use these two equations to come up with a function? So in life, we want to build models, build mathematics models. And those models oftentimes are functions. So we have learned the linear function, quadratic function, especially for quadratic function. In quadratic function, if the leading coefficient is negative, so we will have the graph of the function be downward parabola. And in downward parabola, the vertex is the maximum. So let's see if we can form a quadratic function and it happens the leading coefficient to be negative. In that case, we can find such maximum because it's a vertex on the graph. Well, we have P equals to product equals x times y. And then from the first equation, we can rewrite the first equation as y equals to 24 minus x. Right? Then we want to substitute such y into this one. So product, so P equals to x times y, we use this value, 24 minus x. And now we have only one variable on the right-hand side. So we can think of this product as a function. We call the function P in terms of x. So let's write here. So we have formed the function P of x. So 24 times x, that's 24x. X times negative x squared. Indeed, we have a quadratic function. Indeed, we have formed a quadratic function, and the leading coefficient, which is the number before x squared, is -1. Negative number, the graph of the quadratic function is downward parabola, and this is the vertex is the maximum. So that's this one we're looking for. All right, so how do we find this vertex? So P of x equals to negative x squared plus 24x. So this is in the standard form. Remember, standard form, we have ax squared plus bx plus c. Right, so f of x. And if the function written in this form, so the vertex, the x value in the vertex is negative b over 2a. Well, in our case, b is 24. So we have negative 24, b is 24. 2 times a is -1. So 2 times -1. 24 divided by 2, that's 12. Then we have one negative, another negative, negative times -1 is +1. +1 times 12 is 12. So the vertex value here, the x value is 12. But the maximum means the maximum product. So we want to find the P of 12. So let's write here. So we need to find the P of 12. So we get the 12, we use this form. So we have 12 times, well, if x is 12, we see from the first one, we can see y is also 12, because 24 minus 12, so y is also 12. So 12 times 12, which is 144. 144. So the maximum, so the maximum product is 144. Okay, so what did we do? So we translate the English into mathematical equations. Then we work with the equations to build a model, to build a function, to come up with a function. And to find the maximum for now, when we go to calculus course, we can find maximum by taking derivatives. But for now, we can use the properties of quadratic function to find the maximum by finding the vertex. Okay, that's the first one. Now let's see B. B is saying the number of atoms of a company sells is often a function of the atom's price, right? So the number of atoms a company sells, so this is the number, maybe we use N. So this is saying, if we call the number of atoms a company sells as many in terms of the price. So it's a function. So we have a P price and the number of price to make a function. The revenue a company receives from selling bikes at price P, so this is given price P, is modeled by this function R of P. So the revenue, R represents revenue in terms of the price of the bikes. So R of P equals to quadratic function. And the leading coefficient is negative 2.5. So again, we see a downward problem. This vertex is a maximum. So question, what price will maximize the revenue? So that means we want to find this price and the revenue of the price of this point. So this is a very common question in business. All right, so what do? We do the same thing. So we have in the standard form, right? AX squared plus BX form. So P, the vertex at the value P, R P. So P equals to negative B. B is the number before P, negative 500, divided by 2 times A. A is the number before P squared, which is negative 2.5. Well, then we have 500. Negative and negative become positive. 2 times 2.5, that's 5. 500 divided by 5, that's 100. So the price is 100. So the maximum when the price is 100. Now we need to find R of 100, which is negative 2.5 times 100 squared plus 500 times 100. Now just calculate. 100 squared is 10,000. 10,000 times negative 2.5. Oh, actually, we could do this because we have 100 here. We have 2 zeros here. So we can rewrite this as 5 times 10,000, 4 zeros. And 100 squared is also 4 zeros, 10,000. So that means 10,000 is common factor. So we can factor out 10,000. Then we have negative 2.5 plus 5. Right? We have this 5, this. Then that's 10,000 times 2.5. That's 25,000. Right? So that means the maximum revenue is 25,000. And what price maximize the revenue is $100. $100. Okay. So this is also to follow the function. The function is given. We don't really need this. We don't really need this. Revenue in terms of the price. and the revenue function is given. It's a quadratic function, and the leading coefficient is negative 2.5. So the graph of this function is a downward parabola. In downward parabola, the vertex is the maximum. Now let's see. Suppose you want to frame a collage of pictures. You have 9 feet of strap of wood for the frame. What dimensions of the frame will give you the maximum area? So let's see the collage of pictures, right? Maybe this, usually it's a rectangle, right? Usually a frame of a collage of pictures, usually it's a rectangle. And in rectangle, we have length and we have width, right? And we have 9 feet of strip. So that means to go around the circumference. It means 2W plus 2 length. But this is also L. This side is also W because we have rectangle. That equals 9 feet. And we want to find the length and width, dimensions, length and width of the frame will maximize the area, will make this area biggest. Well, let's call the area A. Well, A, the area of this rectangle is length times width. It's L times W. So we have those two equations to work with. Again, we see W, right? We want to substitute W in terms of L, or maybe we do the same for L. Doesn't really matter, right? So in this case, we have, if we want to rewrite 2W, so 2W equals to 9 minus 2L. Then we divide by 2, W equals to 9 over 2 minus L. We'll substitute into the second one. We see L times 9 over 2 minus L, right? That's W. W is 9 over 2 minus L. Now we multiply, we get 9 over 2L, negative L times L, negative L squared, plus 9 over 2L. Again, we see a quadratic function with the leading coefficient being -1. And then we can find the maximum area, right? Again, we see downward parabola. This vertex is maximum. So how do we do that? Again, we want to find a vertex. How do we find a vertex? Negative B over 2A. So B is right here, not XL. B is the number before L, negative 9 over 2, divided by 2 times 8, or A is -1. Negative of 2 negatives in the product or division, so to become positive. So we have 9 over 2 divided by 2. So 3 layers of fraction. We just multiply the two denominators. So 2 times 2 is 4. So L equals 9 over 4. Then W, the W equals 9 over 2 minus L. L is 9 over 4. Or multiply by 2, multiply by 2. So we get a common denominator of 4. 2 times 9, 18, 18 minus 9, 9. So in this case, actually it's a square, right? Because length and the width are the same. So what is the maximum area? Now we want to find A of 9 over 4. A of 9 over 4, just plug into the function. We have L 9 over 4 times 9 over 4, which is 9 times 9, which is 81. 4 times 4, which is 16. So I have 81 divided by 16. If you want to calculate it into decimals, you may do that here also. Or otherwise, just leave as a fraction 81 over 16. That's the maximum area. Okay, now let's see D. D says Paul needs to use 6 meters of fencing to enclose a rectangular garden, rectangular again, one side of which will be against the side of a house. So what means something like this? We have this rectangle garden, and by this side the border. So this side facing the house. And of course, on the side of the house, we don't want to put a fencing. So in this case, we only have a fence with 2 width and 1 length. Okay. So 2W plus L, right? That equals to 60 meters. What's the question? The question is in what dimensions of the garden will guarantee a maximum area? Again, maximize the area. So A equals to L times W. And we want to rewrite L into 60 minus 2W. Then substitute L into this, into the second one, which is 60 minus 2W times W, which will get positive 60W and negative 2W squared. Again, quadratic function, and with the leading coefficient of negative 2, leading coefficient is negative. We get a graph of the function downward parabola, and the vertex is the maximum. All right, we do the same. We say W equals to negative B over 2A. B is the number before W, 60. 2 times A is negative 2. Again, we see negative and negative, 2 negative signs in multiplication and division. That turns out to be positive. We'll have 60 divided by 2 times 4, which is 15. So if W equals 15, L here equals 60 minus 2 times 15. 2 times 15 is 30. 60 minus 30, which is 30. So the length is 30. The width is 15. We'll make the maximum area. What's the maximum area? That's A of 15 equals to plugging 15 into the function. A of 15 equals to 15. We're going to use this one. 15 times 60 minus 2 times 15, which is 30. So we got 15 times 30, 60 minus 30, indeed 30, right? Then we have 450. So the maximum area is 450. So don't worry about, so this is pure mathematics. Don't worry about the quantity, all right? The unit, don't worry about that. That's D. Now let's see E. A ball is thrown vertically upward from the ground with an initial velocity of 32 feet. 32 feet per second. The formula for this height is given. So the mathematical model is already given. H of t equals negative 16t squared plus 32t. Again, quadratic function. The variable is h comma t and t. So the question is asking, what is the maximum height? The maximum height reached by the ball. Again, we see this downward, this quadratic function, leading coefficient negative. We know the graph is a downward parabola, and the vertex is the maximum. So we need to find its x value and its function value for this vertex. We do the same. So t, because the variable here is t, equals to negative b32 divided by 2 times negative 16. Negative times negative become positive, 32 divided by 2, 16. So now we want to find the maximum height. So h of 16. So when t value is 16, that reaches its maximum height. So maximum height is h of 16. That's negative 16 times 16 squared plus 32 times 16. So we see 16 here. We see 16 here. Maybe you can factor out 16. So factor out 16, I'm going to write here. Then the first one left with is we're factoring out, let's see, should we factor out negative 16? Yes, let's factor out negative 16. negative 16, then the first one we're left with 16 squared, then minus 32. Right? So 16 is a common factor, factor out. Then we have, factor out negative 16. Factor out negative 16. Then we don't have to deal with negative sign later. Negative 16 factor out of 16 squared left for the first term. And the 32, negative 34, because negative times negative will be positive. Now we just have to evaluate 16 times 16 squared. What's 16 squared? 16 squared is 16 times 4 times 4. Right? 4 times 16 is 64. 64 times 4, 6, so 256. So 256 minus 32, which is 11 times, 56 minus 32 is 200. So this is 32. 224, isn't it? We can check 224 plus 321. So that's 5, that's 4, that's 5. Oh, hold on. 256 minus 32. Right? So, right. Or you could use a calculator. All right. Maybe, let me see. Let me use a calculator first. Numbers like this, we don't really need to spend time to calculate. We can just use a calculator. So we get a 16 squared minus 32. That's 221. Then multiply by 16. So in the end, the maximum area is 3,536. Okay. Now let's see E. Let's see if E is the last one. Oh, we have two, E and an F. Oh, E we already defined, right? Maximum height. Right? We already defined the maximum height. So F. So the height h in meters above ground of a projectile at any time t in seconds after launch is defined by the function. So this is the function. So whenever you toss a ball, the trajectory is a parabola. So which means it's a function, it's a quadratic function, especially it's a downward, the graph is a downward parabola, right? Because the trajectory is a downward parabola. So you can see here the model is indeed is a quadratic function with a downward parabola because the leading coefficient is negative. To find the maximum height, we do the same. So t equals to negative b over 2a. We want to find the vertex. The value, the independent variable t here, the value is negative b over 2a. Negative b, so b is the number before t, 48. 2 times a. A is the number before t squared, the leading coefficient, which is negative 4. We still have a negative sign here in multiplication and division. So if you have even number of negative signs, that becomes positive. So we have 48 divided by 24, which is, this is 2, which is 48 is 2, 2 divided by 2, which is 1. Get a positive 1. Well, 2 times 24 is 48, right? 48 divided by 48, indeed, that's 1. So then we want to find the maximum height, which we want to evaluate h of 1. H of 1 equals negative 4 times 1 squared, which is 1, plus 48 times 1, which is 48, plus 3. Well, negative 4 plus 3, that's negative 1. Negative 1, so 48 minus 1, which is 47. So the maximum height of the projectile is 47. So this is pure mathematics, right? We don't involve units in this. So those questions, just using quadratic functions, especially to form a quadratic function with leading coefficient to be negative. So the graph or the trajectory is a downward parabola, by using the vertex to be the maximum to solve those kind of questions.